Hey everyone! In this video what we're going to do is we're going to figure out what the limit is as x approaches infinity of the natural logarithm of x plus the natural logarithm of x divided by x. Now notice that in the numerator, if we just let x tend to infinity, we have infinity, and if we let x tend to infinity in the denominator, we also have infinity. So our limit is of an indeterminate form, infinity over infinity, and in order to evaluate this limit, what we're going to have to use is something called L'Hopital's rule. L'Hopital's rule basically says that if you have a limit as x approaches some value c of a function f of x divided by another function g of x, and f of x is equal to g of x, which is equal to infinity or 0, then this limit right here is equal to the limit as x approaches c of the derivative of f of x divided by the derivative of g of x. So in order to apply L'Hopital's rule, we must have an indeterminate form of plus or minus infinity over plus or minus infinity, or 0 over 0. So let's begin by taking the derivative of the numerator. We have the limit as x approaches infinity. Now in order to take this derivative, we're going to have to use the chain rule. So we'll take the derivative of the outside part and then we'll multiply it by the derivative of the inside part. So we have 1 over x plus the natural logarithm of x multiplied by 1 plus 1 over x divided by, now the derivative of x is just 1, so we just have 1 here. Now we can rewrite the limit above as follows. We have the limit as x approaches infinity of 1 divided by x plus the natural logarithm of x multiplied by x plus 1 divided by x. So all we've done here is just cross multiply. Now multiplying this out further, we have the limit as x approaches infinity of x plus 1 divided by x squared plus x multiplied by the natural logarithm of x. Now notice if we let x tend to infinity, we actually still have an indeterminate form of infinity over infinity, so we're going to have to apply L'Hopital's rule for a second time in order to evaluate this limit. So we have the limit as x approaches infinity. Now the derivative of the numerator is just 1, and this is divided by the derivative of the denominator, which is just 2x plus the natural logarithm of x plus 1. All we've done here is use the product rule. Now if we let x tend to infinity, we have 1 over infinity, and this is equal to 0. And that is the final answer for this problem. Thank you very much for watching. I hope you found this content useful. Please make sure to like and subscribe as it really does help the channel out. I hope you have a great day.